Today is 8th of November, 2024. We will discuss about well-ordering principle and mathematical induction, which can be induced by Archimedian property. This is kind of core part in early analysis. For the mathematical induction, we will say let A is subset of natural number. By the way, can you see my screen, Tobias?
I can.
Okay, I will please let me know if you can't see my screen. I will just share my computer screen. Mathematical induction is defined by when there is subset A, which is natural number. Subset A is subset of natural number. Then if it satisfies two conditions, if one is element of A, and if some natural number n is E in A, and then n plus 1 is also the element of A, then we will say the subset A is equal to natural number n. This is the mathematical induction. You will already learn mathematical induction in high school mathematics, but actually the definition gets a little bit different. Can you guess what's the difference? I will also introduce well-ordering principle. I will call it just W. Oh, this is well-ordering principle. A well-ordering principle is defined by, it is also thing when there is subset of natural numbers. When A is not, A has at least some, when A has element, then there exists the minimum of A. This is well-ordering principle. Now I will see, and I will also look up Archimedian property, and I will share my computer screen very quickly. So let's go deep. Archimedean property, I will say AP. It is, we will, let's say X and Y, which is real number. And we will say X is bigger than 0. Then there exists natural number n, which satisfy such that n x is bigger than y. This was the definition, and I will share my screen to see what it really is. So if you see the screen, then there is mathematical induction, that's what I wrote about, and there is well-ordering principle. And we are see the relationship between each other. If well-ordering principle exists, then in that case, if we say mathematical induction is first, then one where one is the condition 1 and 2, it will not make a it will not make a and n equals. So by contradiction, a is n. So we can prove that well-ordering principle makes mathematical induction. And in other case, it will also make mathematical induction will make well-ordering principle. And for the Archimedian property, it is property that when there is x and y, which is real number, and when x is bigger than 0, there exists natural number n, which make nx is bigger than y. Can you guess what it really is, or what is the usage? It's if you want to really understand the meaning, you should be really carefully look up and read it. In this case, Archimedean property is you want to find the real number, which is the property of real number is when there is x and y, in between x and y, there is real number. But mathematicians wants to know what happens if the gap between x and y is really small. Even like this, then is there a real number between x and y? We can get an answer by Archimedean property, because by Archimedean property, we can multiply n. So this was x and this was y, but we are multiplying n, so we can make a gap. We can make big gap between x and y. So we can get the real number what we want. This is what Archimedean property want to talk about. So after that, we are talking about density of Q, irrational number. Q, rational number. How dense are they? Thank you for listening my lecture. And next time we will come back with mathematics with Markowitz portfolio. Do you have any more questions?
From my side, it's good.
Okay. Then I will finish the lecture today.